This video is for factoring quadratics. Now, when we factor quadratics, I like to use a technique that I call goal number factoring. One thing that we want to focus on is, as you learned, you always want to look for that GCF, the greatest common factor, first. If we have a greatest common factor, we want to pull that out just to make our goal number factoring process a little bit easier. So how does goal number factoring work? The first thing is to find the goal number, you're going to take A times C. So the quadratic has to be in standard form. Take A times C, just the numbers, and that gives me my goal number. I'm then going to determine the factors of the goal number that add to get the middle term. This is where the work is, all right? Sometimes the factors are a little bit hidden, or you really got to mess with the numbers, all right, the factors of the goal number to find the right combination that not only multiplies to give me the goal number, but it also has to add to give me the middle term. Once we find that pair of factors, we're going to divide by A, and then we're going to take those factors and write them as binomials. Now, one thing we want to make sure that we do is not include any fractions in there. So let's take a look at a few examples. Number one here, I've got x squared plus 3x minus 54. Now, this is in standard form. I look across, I notice there are no greatest common factor. There is no common terms between the three. So I immediately go to goal number factoring. I take 1, which is A, times C, which is negative 54, and that gives me a goal number of negative 54 with a middle term of 3. This is how I like to organize my numbers. I know that the factors of negative 54 that will add to give me 3 would be 9 and negative 6. They have to first multiply to give me negative 54 and then add to give me 3. I'm going to divide each by A, which is 1, and now I'm ready to complete the factoring process, which is I'm going to change these into binomials. I like to read them bottom up. So this 9 over 1 really says 1x plus 9. And this negative 6 over 1, read it from the bottom up, that would be 1x minus 6. And that's the complete factorization. So let's try a second example here. Let's say that we have 5x squared minus 22x minus 48. All right, now I look at these, the numbers got a little bit bigger, so I'm thinking maybe there's a GCF, but if I look at 5, 22, and 48, they don't have a common factor. So there is no GCF here. I immediately go to the goal number. 5 times negative 48 is negative 240 with a middle term of negative 22. I know the factors of negative 240 would be negative 30 and 8. They multiply to give me negative 240. They add to give me negative 22. Since my leading coefficient, or A, is 5, I divide each of them by 5. Now, when I look at those fractions, I always like to take the time. It takes 2-3 seconds to rewrite any fractions that can be simplified. If a fraction can be simplified, it must be simplified before you give your final answer. So I know that negative 30 over 5 is really negative 6 over 1, and 8 over 5 stays 8 over 5. I rewrite this as 1x minus 6, again reading bottom up, and 5x plus 8. And that's the complete factorization. All right, let's try another one. Each one I'm trying to get just a little bit more sophisticated. So how about we have 6x squared minus x minus 40. Okay, again, I look, there is no common factor. So I go to my goal number. 6 times negative 40 is negative 240, and the middle term is negative 1. The factors of negative 240 would be 15 and negative 16. 15 times negative 16 is negative 240, and they add to give me -1. I'm going to divide them by a. Both of these fractions can be simplified. I must do that. So 15 over 6, 3 goes into both of them, so that reduces to 5 over 2. Negative 16 over 6, 2 goes into both of them, so that reduces to -8 over 3. I'm now ready to factor or to write as binomials. So I would have 2x plus 5 and 3x minus 8. All right, let's try one more example here. This one, let's throw in a GCF. So let's say that we have 28x squared minus 144x plus 20. And the first thing that I notice here is these numbers are pretty large. There's a good chance that there's a GCF. Doesn't have to be, but there's a good chance. So I look and I notice that each one of the numbers is even. So that means they're divisible by 2. But are they also divisible by something larger than 2? Well, I know that 4 would go into all of them. And I don't believe there's another number. So I'm going to show you how I can double check when I'm not sure at the end here. All right. So the first thing I'm going to do is I'm going to divide each one of these terms by 4. That 4 is my GCF. I'm going to rewrite this as 7x squared minus, what would that be, 36x plus 5. Now, this will give me a goal number. I don't see any GCFs there for sure, so 4 was definitely my largest term. But I'm going to do goal number factoring now. I get a goal number of 35, middle term of -36. Factors are -1 and -35. Divide them both by 7. I have a fraction to simplify, so I'm going to do that. And now I'm going to take all 3 of these pieces, this piece, and this piece, and all together write the factored form. So I write my GCF first. -1/7 would be 7x minus 1, and -5 over 1 would be 1x minus 5. Now, I'm pretty confident here. One way that I could check to make sure is I could simply multiply the first term, or the 4, the 7x, and the x together, and that should give me the first term of the quadratic we started with. Hope this helps. Let me know if you have any questions.